Hydrogen bonding is the strongest type of intermolecular forces, and it is also the most selective. So for hydrogen bonding to occur, hydrogen must be covalently bonded to oxygen, nitrogen, or fluorine. And that hydrogen will interact with a pair of electrons on oxygen, nitrogen, or fluorine. Hydrogen bonds, like intermolecular bonds in general, are illustrated as dashed lines as opposed to the solid lines we use for covalent bonds. So table 7.1 of your textbook summarizes the requirements for hydrogen bonding. The hydrogen, which has a partial positive charge, must be covalently bonded to an oxygen, nitrogen, or fluorine. And that hydrogen will interact with a lone pair of electrons on an oxygen, nitrogen, or fluorine, which will have a partial negative charge. So there's still an attraction between a partial positive on the hydrogen and a partial negative on the electronegative atom. But it is a very, very special type of interaction, and it's much stronger than a normal dipole-dipole interaction. So let's look at some illustrations. On this slide, on the left, we have a Lewis structure of a molecule that has an ether functional group, so this oxygen singly bonded to two carbons, and then an alcohol functionality. So the alcohol functionality has a hydrogen that can hydrogen bond because it's bonded covalently to an oxygen. This hydrogen can bond or hydrogen bond with the oxygen in the ether. Let's look at another example of hydrogen bonding. This is between two different molecules. So we have water depicted here, as well as this ketone, which is known as acetone. So water has hydrogen that is covalently bonded to oxygen. So these hydrogens can hydrogen bond. And they will hydrogen bond with the lone pairs on the oxygen in this ketone functionality. So this is hydrogen bonding. And notice that the hydrogen bonding is indicated by that dashed bond. And here's another example. This molecule is ethanol, or ethyl alcohol. And the hydroxyl group, which is the alcohol functionality, has a hydrogen covalently bonded to an oxygen. So this hydrogen can can hydrogen bond with the oxygen in a water molecule, and the hydrogen atom on a water molecule can hydrogen bond with the oxygen in the alcohol functionality. So there's lots of hydrogen bonding possibilities because there are two substances that have oxygen and two substances that have hydrogen covalently bonded to oxygen. This is one of the reasons why ethanol is very, very, very soluble in water. Now notice that each of these molecules have hydrogen bonded to carbon. These hydrogens will not engage in hydrogen bonding. For hydrogen bonding to occur, it must meet this very strict criteria where the hydrogen is covalently bonded to oxygen, nitrogen, or fluorine.